assume that x is a function of t, and let's assume that y is also a function of t. Then our goal is to find the derivative of x with respect to 2 by using the following information. So what kind of information do we have? Here you can see we have a relationship between x and y, right? Given by x square plus y square equal to 8.73. So we have a relationship between x and y, and we have also given the rate of change of y with respect to t, which is given as -4. And that is actually true only when this rate of change is true only when x equal to -2.7 and y equal to 1.2. So how can we solve this type of related rate problem? You know that in the related rate problem, we either will have given a relationship between some quantities. So like here we have a relationship between x and y, right? Or if that is not given, based on the given information, we need to come up with a relationship between the given quantities. So since we have already given the relationship between x and y, so let's use that fact. Alright, so let's try to begin from there. Alright, so we have given the relationship between x and y as x square plus y square is equal to 8.73. Right, so this is one of the given information. And then what is the question here? We need to find, right, we need to find derivative of x with respect to t. So this is what we need to find out. That means we need to figure out the rate of change of the x with respect to t. And what else information we have? We have given actually the rate of change of the y with respect to t is -4 when x equal to -2.7 and y equal to 1.2. So we try to figure out the rate of change of x with respect to t when x equal to -2.7 and y equal to 1.2. Alright, so how do we work on the related rate problem? So on the related rate problem, like I said earlier, we need to first either come up with a relationship between the variables or the quantities, or we will have given that information. On this case, since we have given this information, let's begin from here. So what we do here is, now once we have the relationship between x and y, since our goal is to find the rate of change of x with respect to t, so we will differentiate with respect to t on the both side of this relationship. So on that means let's differentiate x square plus y square with respect to t on the left hand side. Let's do the same thing on the right hand side. Let's differentiate 8.73 with respect to t. So on the right hand side, since we have a constant, so derivative of the constant with respect to t will be 0. So that's why we can immediately write down the derivative of that constant is 0. Right? How do you find the derivative of x square plus y square? We use the sum rule. So we find the derivative of x square with respect to t, right? And we also find the derivative of y square with respect to t, and just add the derivative together. So in that case, let's find the derivative of x square with respect to t. Alright, so what is the derivative of x square? You can notice here, this is x here, right? This is t. We have a different variable there. So if that is the case, how do we differentiate? Well, we need to make sure if x is actually a function of t, and that's what we have given. You see those assumptions given over here, right? So we have actually given the assumption that x is actually function of t and y is also function of t. We need to keep that in our mind. So if that is the case, since x is a function of t, to differentiate that with respect to t, we assume this is like a function, some function raised to the power something. So on that case, we use generalized power rule, right? Which is bring the power down, write down the function as it is. So x is as it is, subtract the power by 1. So 2 minus 1 will be 1. Don't forget to multiply by the derivative of that function, which is x on this case, with respect to t. So that's how we find the derivative of x square with respect to t, since x was a function of t, right? So that's why we needed to do that. In the same way, since y is a function of t, we have given that. So in that case, to find the derivative of y derivative of y square with respect to t, we do the same thing. Bring the 2 down, write down y as it is, subtract the power by 1. So 2 minus 1 will be 1. Multiply by derivative of y with respect to t is equal to 0. So what is the benefit of this? Now you might have noticed it's actually now we have a relationship between the rate of change. Earlier, originally, we have given the relationship between the variable. Now we can see that here we have the relationship between the rate of change. There is derivative of x with respect to t, there is derivative of y with respect to t. So that means the rate of change are related with each other. That's why it's called related rate problem. So if that is the case, let's try to find the derivative of x with respect to t, which we needed to figure out. Okay, so but we know that we need to figure out the derivative of x with respect to t only when x equal to minus 2.7 and y equal to 1.2. Since we have the relationship between the rate of change here, why don't we just plug this information in? Okay, let's try to do that then. So 2 is a constant, write down as it is. Now since x is here and then x is 2.7, right? So that's what we have given over here. So let's plug that in over here and then we get 2.7, and then we needed to figure out derivative of x with respect to t, so that is unknown, right? So we write down that as it is. So derivative of x with respect to t, and plus again now we have a 2 here, so let's write that down, constant. Okay, and then after that we have y, and y is given also here as 1.2, so we can also write that down. Okay, and what else we have? Derivative of y with respect to t. When x equal to 2.7 and y equal to 1.2, we have given here the derivative of y with respect to t is actually negative 4. So if that is the case, we can plug that information in here, right? So negative 4, we can just plug that information in. All right, so this is now then equal to 0. Okay, now let's try to simplify a little bit. 2.7 times 2 will be, what will be that? Do we have 2.7 by the way? Sorry. Okay, here we have negative 2.7. Some of you kind of noticing what is going on here, right? Okay, let's write down negative 2.7, whatever is given. So that was the x value. All right. Okay, all right, so let's try to find. So negative 2.7 times 2 will be negative 5.4 multiplied by derivative of x with respect to t plus, now let's multiply all of these constant together, then what do we get? For negative 4 times 1.2 times 2 will be negative 9.6, so plus 9 will be negative 9.6, right? So set that equal to 0. So you might have noticed now actually derivative of x with respect to t is the only unknown. So to solve that, how you would solve the linear equation, in the same way we can solve this one, right? So how do we do that? We make the derivative of x with respect to t alone, or we isolate that. To do that, what we can do first is add 9.6 on the both sides, so then this will be equal to 9.6, right? And then after that, to isolate derivative of x with respect to t, we can divide both side by negative 5.4. So negative 9.6 divided by 5.4, right? You could write down 9.6 over negative 5.4, but that's the same thing. So this is our rate of change of x with respect to t for the given information. Alright, so we are done. But if you want to rewrite this, actually 9.6 divided by 5.4, if you want to write down on a kind of fraction, this can be also written as 16 over 9, right? And negative 16 over 9. Or if you want to write down on approximated values, so this will be negative 1.78, something like that. All right, so this is how we can find the rate of change of x with respect to t. So on the related rate problem, you might have noticed there are a couple of steps we need to be very mindful. One is we need to look into the relationship between the variables, right? So that is one of the major steps. So when we have that, once we differentiate with respect to t on the both side, we will come up with the relationship between the rate of change. So we need to have given the relationship between the variable, or we need to come up with that, and when we differentiate with respect to t, we'll get a relationship between the rate of change, and then based on the given information we can compute the necessary thing.